If you've watched One Piece, you've probably seen islands where the weather seems impossible. Places where storms never end. Where nature follows its own rules. Feels like fantasy. But there is a place on Earth that comes surprisingly close. A place where lightning strikes so often that the night sky can glow for hours. A place sailors once used as a natural lighthouse. A place where storms have appeared for centuries. And unlike the Grand Line, this place is real. So why does lightning keep returning to the exact same location? And how did one corner of South America become the most electrified place on Earth? Most thunderstorms come and go. A storm forms, rain falls, lightning flashes, then the sky clears. Catatumbo Lightning doesn't behave that way. Near the place where the Catatumbo River meets Lake Maracaibo in Venezuela, lightning appears again and again, night after night, month after month, year after year. Observers have recorded hundreds of stormy nights annually. On some nights, thousands of lightning flashes illuminate the sky. The phenomenon is so consistent that it can often be seen from hundreds of kilometers away. For centuries, local people have watched the storms dance above the horizon. Long before meteorologists arrived, long before satellites existed, the sky itself had already become part of local identity. Early sailors navigating the Caribbean reportedly used the distant flashes as a natural beacon. A lighthouse created by nature, the storms became famous throughout the region. Yet fame did not bring understanding. People knew the lightning existed. They simply didn't know why. And the deeper scientists investigated, the stranger the answer became. Because the secret wasn't in the lightning itself. It was hidden in the landscape. To understand Catatumbo Lightning, you first need to look at a map. Lake Maracaibo is enormous. Surrounding it are mountain ranges on three sides. The Andes to the southwest, the Parija Mountains to the west, the Venezuelan coastal range to the north. Together they create a giant natural basin. During the day, tropical heat builds across the region. Warm, moisture-rich air rises from the lake and surrounding wetlands. Meanwhile, cooler air flows down from the mountains. As evening approaches, these air masses collide. The result is atmospheric instability on a massive scale. Clouds rapidly grow upward. Electrical charges begin separating inside them. Positive charges accumulate in one region. Negative charges in another. Eventually, the imbalance becomes too great. The atmosphere releases enormous amounts of energy. Lightning. But here's what makes Catatumbo different. Most places experience these conditions occasionally. Catatumbo experiences them repeatedly. The geography acts like a machine designed to manufacture thunderstorms. Night after night, the same ingredients come together. Warm moisture, mountain winds, tropical heat, atmospheric instability. Again, and again, and again. Nature keeps rebuilding the storm. The result is one of the most reliable lightning-producing systems ever observed. Yet geography alone doesn't fully explain the phenomenon. Scientists suspected another ingredient was helping fuel the process. And that led them toward the water itself. For years, researchers debated whether Lake Maracaibo possessed some special property. One theory focused on methane. The lake sits near extensive oil and gas deposits. Some scientists suggested methane released into the atmosphere might enhance electrical activity. The idea attracted attention because the region contains some of the largest petroleum reserves in the world. At first glance, the theory seemed plausible. More gas, more energy, more lightning. But evidence remained limited. As research improved, most scientists began favoring a different explanation. Moisture. Enormous amounts of moisture. Lake Maracaibo constantly feeds water vapor into the atmosphere. The tropical climate amplifies the process. Warm air can hold large quantities of moisture. When that moisture rises and cools, it condenses into towering storm clouds. The larger the cloud system becomes, the more opportunities exist for electrical charge separation, and the greater the chance of lightning. Modern satellite observations revealed that Catatumbo's location consistently generates some of the highest lightning densities on Earth. Not because of a single magical factor, but because multiple favorable conditions overlap in one place. It's like hitting the atmospheric jackpot. The right geography, the right climate, the right humidity, the right winds, all operating together. What makes Catatumbo extraordinary isn't one extreme variable. It's the fact that so many variables align at the same time. And the consequences extend far beyond creating a spectacular light show. Because lightning changes the atmosphere itself. Every lightning bolt releases tremendous energy. For a fraction of a second, temperatures inside the bolt can become hotter than the surface of the sun. That energy doesn't simply disappear. It alters the surrounding air. One result is the production of nitrogen compounds and ozone. For years, some people even nicknamed Catatumbo Lightning the ozone factory. That description is somewhat simplified, but it reflects a real scientific question. Can enormous amounts of lightning influence atmospheric chemistry? The answer is yes. Lightning plays an important role in natural chemical processes occurring in Earth's atmosphere. It helps transform gases. It contributes to nitrogen cycling. And because Catatumbo produces so many lightning strikes, scientists view it as a valuable natural laboratory. The region allows researchers to study interactions between climate, weather, chemistry, and geography. In other words, Catatumbo is more than a spectacle. It's an experiment that nature has been running for centuries. But if this phenomenon is so important, why don't more people know about it? Part of the answer lies in where it happens. Unlike Niagara Falls, unlike Mount Everest, unlike the Grand Canyon, Catatumbo Lightning isn't a place most tourists can casually visit. The storms occur in a remote region. Access can be difficult. Conditions can be unpredictable. And much of the experience happens at night. As a result, millions of people have never heard of it. Yet among meteorologists, it is legendary. Satellite systems continuously monitor it. Researchers study it. Weather enthusiasts dream of witnessing it. Because even in a world filled with advanced technology, seeing thousands of lightning flashes ripple across the horizon remains unforgettable. The phenomenon reminds us that nature still possesses the ability to surprise. Not because it breaks the laws of physics, but because it follows them so perfectly, which raises a larger question. What happens if the environment that created Catatumbo Lightning begins to change? Nothing in nature remains completely unchanged. Climate patterns shift. Temperatures rise. Wetlands expand and contract. Human activity alters landscapes. Catatumbo lightning depends on a delicate combination of factors. If enough of those factors change, the phenomenon could change as well. Researchers have already observed periods where lightning activity weakened, then later intensified again. The system is powerful, but it is not permanent. Future climate changes could influence rainfall, wind patterns, humidity levels, and the stability of the atmosphere itself. No one knows exactly how the phenomenon will evolve over the coming decades. But one thing is certain. The world's most famous lightning storm is not guaranteed to remain exactly as it is today, which makes its existence even more remarkable. Because every flash is part of a natural process that may never be perfectly replicated anywhere else on Earth. When people first hear about Catatumbo lightning, they imagine an endless storm, a place where the sky refuses to stop flashing. And in many ways, that's true. But the real wonder isn't the lightning. It's the extraordinary combination of geography, climate, water, and atmosphere that makes it possible. A phenomenon so rare that it feels like fiction. A place that seems as though it belongs in a fantasy world, yet exists right here on Earth. And perhaps that's the most remarkable thing about Catatumbo. Not that it looks like something from One Piece, but that reality created it first.